So first, how many paired data set do we have? 3. What is the degrees of freedom? 1. Okay, so now you have a basic information before you analyze the data. Next, click Analyze, correlate, bivariate. You move two variables, two dependent variables. They are dependent on each other. Once you click, okay, do you see a table that has a diagonal values? 0.982, 0.982, they are the same. Good. 0.12, 0.12, and 3.3. Good. Okay. What is your conclusion? What is their relationship? 0.982, right? 0.982. Is this positive or negative? Positive. How positive are they? Strongly positive, correct? That is not all to report. Next, well, looks like there is a strong positive correlation. But are you sure? Truly, there is a positive, strong relationship. Then you need to look at statistical significance. Statistical significance. What is their error rate? 12%. 12%. 12% is way over than 5% that we accept, correct? So 5% of error, p-value at 0.05. P-value at 0.05 is the most acceptable, most generous p-value in any field. Psychology, physical education, kinesiology, physical therapy, allied health, doesn't matter. 0.05, yeah, people make mistake. 5% of error is always acceptable because 95% is anyway true, right? What about if you work in a medical field? Well, you don't want to make any mistake, right? You don't want to kill 1 out of 100 patients, still too much. Then you gotta be a little bit more strict with a p-value at less than 0.001, correct? So you might kill your client, a patient during operation, 1 out of 1,000. Still, you're acceptable. You are a significant doctor, right? What if you kill 5 patients during surgery? You are insignificant. More than 5, insignificant, correct? Okay. Next, how can we make sure that correlation coefficient 0.982 is not significant that we say? Do you still have a course class note? Page number 14. Do you have it? No? Right there, if you don't have it. Page number 14. You have a second table that you should have and that you should understand how to interpret. Okay? That is called Pearson correlation coefficient table. We had only 3 data sets, correct? We had only 3 data sets. 1, 2, 3. To find out the true relationship, you gotta compare your data to the population. The population means actual truth of their relationship, right? So, do you see DF? DF, the first column DF. When your DF is 1, right there, DF is 1. DF is 1, right there. If you allow 5% of mistake, right there, 0.05, correlation coefficient should be equal or greater than 0.997. Just remember, 0.997 equal or greater than 9.997. Let's take a look at our value. 0.982. So our value correlation coefficient is less than what is recommended by this table at p-value 0.05. So now you see two information on the top, one tail. The second level, do you see two tail? Do you see, remember one tail and two tail? One tail means only one side with the normal distribution. Two tails, you are looking at both sides. 99.99999% of data analysis will go with two tails. So the first top part, please disregard it. So you look at two tail test right there, and take a look at the error rate that you allow. 0.05, 0.01, 0.001. That is the p-value. P-value. Okay, let's practice with one more. 4, 4, 4, 5, 6, 7, 8. Okay, next. 6, 8, 10, 11, 9, 8, 7. You ready? We got 8 minutes to go. So we have two variables, x and y. So before you go to further analysis, what is the degrees of freedom? How many paired data set do we have? 10. 10 minus 2 equals 8. What if you don't see 7 right there? What is degrees of freedom? How many paired set of data do we have? 9, not 10, right? Correlation is dependent. This data is missing. So what is degrees of freedom in this case? 9 minus 2 equals 7. Okay, I'll just keep it right there. So before you analyze this data, what might be the relationship? When x goes up, y goes up, or y goes down? What is a trend here? When x goes up, y tends to go up, right? That is your rough estimate. But if you want to analyze more precisely, just go to correlate, bivariate, click it, and you got x and y variables. We are doing correlation coefficients using Pearson product model, which is the most popular. You want to make sure if this analysis is meaningful, significant, and this box is checked. If your outcome is significant, important, you will see flag with a star. Okay, so let's calculate here. Before we click OK, if you have df of 8, df of 8 at 0.05 level, what is the recommended correlation coefficient on the table? 0.632. And that means your correlation coefficient. This value should be equal or greater than 0.632, right? Our value should be equal or greater than 0.62. Let's take a look at our value. What is our value? 0.518. Less than what is recommended. For that region, do you see any star? No. Is this significant or insignificant? Insignificant. Okay, insignificant. The region is what is p-value that you see? Significance level. 12.5% of error significant. That means it is not significant, insignificant, because of too many errors. Okay. Too many errors. No. What's a good data? Let me see. Do you have a test review? Okay, this is from your first test. First test. Let's try to find out relationship between your written test and lab test. What is a relationship? If you do well on your written test, are you going to do well on your lab test or vice versa? So I'm going to analyze their relationship, correlate, bivariate. I'm interested in the relationship between written test and lab test. Click it. Do you see any star right there? How many stars do you see?
2.
What does 2 star really mean? 1 out of 100, right? 99% true. You are confident. You are confident. Next, how confident are you? I am making almost no mistake to report. There is strong, no. There is a moderate but positive correlation between written and lab test. Written and lab test. Good. We have 33 students who took the test. What is the degrees of freedom? 31. 31. When you have a DF31, what is the recommended p-value? P-value 31, right? 31 right there. 31. Do you see 31 here? You don't see 31, right? If you don't see your exact DF, you always go one level below. So you go with a 30 right there. Good? 30. Do you see 31? No, right? So what is the next level? One level down. 30. What is the recommended correlation coefficient? 0.349. When you have 33 paired numbers, if you are looking at any significant, statistically meaningful relationship, your correlation coefficient should be equal or greater than 0.349. That is the recommendation, 0.34. However, our data is showing 0.632. That is way more than what is recommended. That's why you see 2 stars, 2 stars, 2 stars, less than what is recommended right there. 2 stars means what? 0.01. 0.01. If you allow only one mistake out of 100, still correlation coefficient, which is recommended with this table, is equal or greater than 0.449. 0.449. 0.449. Our value is even bigger than 0.449. That's why you see 2 stars. That's why you see 2 stars. Okay. Okay. For your Wednesday test, I'm going to ask you straightforward. What is the relationship between 2? Yeah, that is a positive and moderate, right? Because 0.62. Are they statistically significant? If you see any star right there, that's one way that you can answer. Yeah, that is significant because I see more than 1 star. Or you can answer, well, below the correlation coefficient, I see 0% of errors. That is way more than 1 out of 1,000 mistakes. That is common in statistics. Got it? Good. So just make sure how you find out up to there.